Derivatives of tangent, cotangent, secant, and cosecant. Well, what I would suggest is making sure you write down what they are, their identities, and then piecing them out and going through what you need to for each one. So, you're expected to be able to memorize them at higher levels, but just being able to use them at a lower level is pretty much what our goal is here. So let's get down what each one is. So we already know sine and cosine. Sine and cosine are done. Derivative of sine is cosine. Derivative of cosine is negative sine. All right. So now we need to deal with tangent, cotangent, secant, and cosecant. So tangent, the derivative, is equal to secant squared. But secant squared is not something that we usually memorize. We look at it as the reciprocal of cosine. So this would be actually 1 over cosine squared of x. So as we do it, usually we would do this one to execute what the actual value would be. But we need to know both because it's very easily could be like a test question. D dx of the next one. Got cotangent next. Doesn't matter your order here. Just getting the last four. Derivative of cotangent is negative cosecant squared. Cosecant is really sine, the reciprocal of sine. So it'd be negative 1 over sine squared. And once again, we would be utilizing the sine, not the cosecant, since we're actually doing these as applications. But if this were generalized, usually it would be this cosecant squared. As a general answer, as a specific answer, and applying it, we would use the other ones. And depending on your calculator could probably be okay with these. The next one. Secant is next on their list. I always remember secant. If I reverse the letters here, that would be a C and an S in front. So that would be your cosine. So it's a reciprocal of cosine on this one. But that's actual secant. I don't want to confuse the issue. We're looking at these over here. See, there's secant. That's why it changed into cosine. Cosecant is the default for me. That's why it's sine. And so the derivative of secant is secant tangent. Which, if we applied it, tangent is sine over cosine. Secant is 1 over cosine. We put that all together, and you would have sine over cosine squared. And the last one, cosecant. The derivative of cosecant is negative cosecant cotangent, which is equal to cotangent is the flipping of sine over cosine is the flipping of tangent. So it'd be cosine over sine. And then cosecant is the flipping of sine. Put that all together, and you're going to have, we still have the negative, cosine over sine squared, negative. Okay, so these are the ones that you're expected initially to memorize. So it'd be like to memorize these. And then to apply, you would use these. Okay, and then, like I said, you can just link them together and build them if you have to apply them. All right, so make sure you get these down in your notes, and let's go ahead and attack this cotangent problem. So negative cosecant squared equals negative 1 over sine squared x. Try to put that in your memory. As always, I recommend trying to remember whenever you're using one of these, and then check your notes to be sure that you've done it correctly before moving on. So practice in your memory. Cotangent is cosecant squared, the derivative. All right, even just for a second, do you remember what the derivative of cotangent is? Cosecant squared x. Cosecant is the reciprocal of sine. So 1 over sine squared x. And I'm just going to check my notes to make sure I've written it down correctly. Cotangent is negative cosecant squared. So I missed that negative sign. Good. And then that's my recommendation. When you're practicing using your memory, try to use your memory, try to remember it, and then check your notes after you've written it down, and then make any corrections and try to adjust. And keep doing that. The more you use your memory, the easier it gets over time. Okay, so that means I've already done the derivative of cotangent, which is negative cosecant squared, and I'm plugging in 5 pi over 3. All right, so I'm just going to go ahead and jump right into the application one since that's the one I need. So that means this is equal to negative 1 over sine squared of 5 pi over 3. Okay, let's remember SOHCAHTOA. What's sine? SOHCAHTOA. So if we get to a triangle, it's going to be the opposite over the hypotenuse. But let's see how this plays out. It's kind of hard to see it, the 5 pi over 3. I don't have these memorized. I build them each time. So let's go ahead and try to build 5 pi over 3, the triangle that's associated to it. So I use the unit circle. That's my technique, or the technique I like to use. And then we're in terms of radians here. So I'm going to do mine in terms of radians. So that's 0 and 2 pi. This would be pi over 2. This would be pi. And this would be 3 pi over 2. Now the technique is, since we have a denominator of 3, I want to look at all of these in terms of a denominator of 3. That way I can see what quadrant it lands in, and then I can start dealing with it that way. So what's the common denominator for a denominator of 3 and a denominator of 2? So that's kind of our goal here. It would be 6. So I'm going to make all of these in terms of a denominator of 6. That way we can compare them. So I'm going to look at this as 2 pi over 1, and this is pi over 1. And I would multiply top and bottom by 3 here. That's going to give me 3 pi over 6. Multiply top and bottom by 6. That's going to give me 12 pi over 6. Top and bottom by 3. That's going to give me 9 pi over 6. And then top and bottom by 6. That gives me 6 pi over 6. Now, when I think about the 5 pi over 3, I need to change that one too. So this would be times 2. So my side work here for 5 pi over 3 times 2, I get 10 pi over 6. All right, so this is really 10 pi over 6 right here. Let me go ahead and I'll just erase this. So this is a 10 pi over 6. So this is the one I'm dealing with. Where does 10 pi over 6 land? What quadrant does it land? So notice having a common denominator all the way around here, and usually we travel in this direction. We would go around. 10 pi over 6 is bigger than 3 pi over 6. 10 pi over 6 is bigger than 6 pi over 6. 10 pi is bigger than 9 pi over 6. 10 pi over 6 is less than 12 pi over 6. So now I can clearly see, and it's closer to, I just like to draw it if I can, a little bit, how close it should be. It's a little bit closer to the 9 pi over 6 or 3 pi over 6. So just as an estimate, it'd be right there. All right, and that's our 10 pi over 6. All right, To do these, we always do a reference angle to the x-axis. So that means it's going to be on this side of the x-axis. Our reference angle means we drop straight down. And create a right triangle with it. Okay. When I look at this, we always let the hypotenuse is 1 because this is a unit circle. And let's see, what do we have here? So sine is opposite over hypotenuse. So I can get rid of some of this side work here. Do my best on it. See how it goes. All right. Sine of x is going to be equal to opposite over hypotenuse. All right. So let's see. It's been a while since I've done one of these. So looking at my reference angle, 10 pi over 6. All right. So the next thing I like to do is, I have this kind of done in pieces for me, is I think about tangent. I know it's kind of a side step. Tangent is sine over cosine. I have that memorized, which is y over x. Okay. Sine is the y component. Cosine is the x component. Okay. So I am looking for the y component here. What is this value? And let's see. How to do it. Trying to remember. Blanking right now. Let's see. Well, let me see what, I'm just brainstorming. I need to get, if I get one of these other sides, I'll be okay. Usually when doing these, it would land in a, like a 30-60 or a 45-45 triangle. So let's see what the relationship is between this x-axis, okay? All right, so I have, so basically what I'm trying to do now is, what is this angle right here? This angle given off my triangle. All right, let's see if we can find out what that angle is, and then we can start throwing some more trigonometry at it. Okay, so all the way around was 5 pi over 3. So I'm just going to 5 pi over 3 because I keep looking at this. All the way around was 5 pi over 3. So what is it that compares to this this angle right here? So that's what I'm trying to find out. What's that angle right there? Okay, so to find that, we compare it to the x-axis on this side, which is either 0 or 2 pi. All right, so let's go ahead and use the 12 pi over 6 and the 10 pi over 6. So that would be 12, I don't like that color, 12 pi over 6. And we're going the other direction here. So that's going to be, it's like a negative angle, but when we do it, we'll just drop the negative because it's the same as an angle. So I'm going to be subtracting 12 pi over 6 from our angle of 10 pi over 6. All right. So this now tells us that it is negative 2 pi over 6, and which reduces down into negative pi over 3. Okay, now that we can use. We can still do this like using inverse trig if this wasn't an easy one, but it definitely is. So I'm going to think about this as we're going in this direction, so it's negative. I was just kind of using that as a reference. But I'm going to go ahead and drop that negative so we can deal with this using our trig. So I'm going to focus on pi over 3. So I just found out this is equal to pi over 3. Now for me, I have my degrees memorized, not my radians. So I'm going to go ahead and just convert that. So pi over 3 times pi on the bottom to cancel it, and 180. 3 goes into 180 60 times, so, and the pi's cancel. So this is a 60-degree angle. All right, so this is equal to 60 also, 60 degrees. All right, so I'm going to go ahead and focus on the 60-degree special right triangle. If it wasn't a 60, 30, or 45, then we would use inverse trig, I believe, to get it. That would probably get us to where we need to, but we can just do the trigonometry of it. So now back to special right triangles. The bottom is 60 to me, how I memorize it. The top is 30. Goes 1, 2, radical 3. Now I'm just looking at the proportions. If I was actually fitting this, notice that that's a 2 and that's a 1. But I'm just looking at the proportions here, so the answer will be the same proportionally. And we're looking at sine. Sine is opposite over hypotenuse. So basically all of this turns into what's the sine of 60 degrees. And then we have to remember it's in quadrant 4. So that means the y value that we talked about, it has to be negative. So our final answer is going to be negative. All right. So the opposite of 60. So we're looking at sine of 60 now. Opposite is radical 3 over hypotenuse is 2. So sine of 60, I get negative radical 3 over 2 as my final answer. Negative radical 3 over 2. Let's see. Not one of our solutions. Not one of our solutions. Let me just go back through, see what I did wrong. Let's see, would that negative change it? No, still no pi over 3. Definitely, I know it has to be one of these. These are the only negatives. It landed in quadrant 4. Sine is the y value, so it has to be negative. And let's see. I'm leaning towards the radical 3 right here. So that's I'm pretty sure that's the answer right here. Everything kind of indicates that. Notice I'm just missing that 2 on the bottom. So not the best way to get to bounce around and get to the answer, but I'm pretty confident about it. So I'm going to go ahead and just pick on that one, and then we'll look at their solution to see what my mistake was. All right, so let's just go through the process, what I did here. All right, so First, the derivative of cotangent is negative cosecant squared. Did I forget to square it? I did forget to square it. Okay, that helps not going through it. So I'm going to go ahead and unclick that. So what I did is I found the sine of 5 pi over 3, which is this. And then we're squaring it, so it is not going to be negative. All right, so that was my mistake, is I did not square this. So good thing I walked myself through it again. So I found sine. So all I've done is I found sine of 60 degrees right here, which is all my work was good. I found sine of 60 degrees in quadrant 4, which is this. And then I need to plug it into this formula now. Okay, boy, that was a close one. I almost clicked on the answer before I was ready. All right, good thing I went through it again. So I'm going to go ahead and use blue this time. So I found out that sine, so I found out that this is in quadrant 4, so in Q4, this is negative radical 3 over 2. Right, so that's basically what I found right here for the 5 pi over 3. I now need to square it and put a negative sign in front of it. Okay, so all this is going to turn into, basically, I got 1 negative, so I'm using this, negative 1 over sine of 5 pi over 3. All of this gets squared. So that's what that sine squared means, is that I'm squaring the entire sine function right here. Negative sign means I negate it, and then this is going to be on the bottom. Okay, good. That's another thing I forgot. It's on the bottom, so then it's going to be a reciprocal idea. Whew. All right, so that finally gives us, I found out that this turns into negative 1 over negative radical 3 over 2, and all of that gets squared. Whew, all right, I'm getting closer. I can feel it. Okay, I guess I'll do my work over here. Taking so long, the computer's starting to slow down on me. So, sorry about that. All right, and got it. Okay. All right, so negative 1 over, and then now I'm going to square it. So that becomes, I square the top and I square the bottom. There's no negative. So that now becomes 3 over 4. Good thing I didn't have one of the answers of just negative 3, radical 3 over 2. I probably would have clicked on it real quick. All right, so that's now squared. And then on the bottom basically means I'm flipping this fraction. So that's a reciprocal idea, and then a negative in front. I got negative 4 over 3. That's my answer that I feel confident in. Ooh, yay, there it is right there. Boy, I almost clicked on the wrong one. Okay, so yikes. Let's go ahead and go through the process here. I know this was a long problem. I had students write me essays. A lot of students said how much trouble they have with trig. Well, you're not the only one. So it's just a matter of taking your time, doing your best, going through, throwing all your techniques at it and seeing what sticks. And like I said, looking through their answer to see how you did on it. Okay, so the first thing I did for this f of x equals cotangent, find the derivative of this function with 5 pi over 3 in it. Okay, first, the derivative of cotangent is negative cosecant squared. When we're applying something and putting a number in it, we do not use the cosecant. We would use the idea it's the reciprocal of sine. So that means it flips it, put sine on the bottom, it's still squared, and there's still a negative sign. Okay, so then the next thing I want to do is I need to find out what quadrant it is in. So what quadrant it's in means that I need to have a common denominator. So I draw my unit circle. I make, since this is 5 pi over 3, I make every denominator in terms of 6 on the bottom, and I write out my unit circle. I find out that 5 pi over 3 lands in quadrant 4. I then create a reference angle with this to see it as a triangle. When I have that reference angle, that means I need the degree of the angle that's right here. Then I can start throwing trigonometry at it. To find the degree of this angle, I would subtract it from the 2 pi or from the 0. Either way would work. I use the 2 pi. I found out that this angle right here is pi over 3. Pi over the 3 is the same thing as 60 degrees. That means I can use special right triangles on it. If it's not a special right triangle, then we would use normal trigonometry and our calculators on it. But whenever it's a special angle, 60, 30, 45, 90, 180, 270, things like that that are real common, then you're expected to get exact answers. Anything else, you'd probably be okay with decimals. In this case, we got a 60 degrees, so we have to get the exact answer here. So I went ahead and I did my special right triangle, and I did the sine of 60 degrees, and I made sure to remember that we're in quadrant 4. The sine of 60 degrees in quadrant 4 is negative radical 3 over 2. Once I have the sine of 60 degrees, I can now plug that back in to the application function. I then have to square it, flip it, and put a negative sign in front of it. When I've squared it, flipped it, and put a negative sign in front of it, I got negative 4 over 3, and then that's our final answer. So all that work, it better be right. Negative 4 over 3. Woo. So let's just get through one problem on this. Notice how epic these problems can be. Not only is there calculus on it, there's trigonometry, and it's real easy to make a mistake or get lost in your trigonometry like I almost did. But what saved me was going back through, looking through my steps, not having the easy answer that was readily available to get me stuck, and I was able to go back through and see my mistakes, which was the first time around. I did not square it, or I did not actually execute the final cosecant idea. I wanted to stop at sine. Okay, so just remember that I know a lot of you have expressed how difficult the trigonometry is, and like I've said, you're not alone. Trigonometry is difficult. You can kind of see all the steps that are required and how many kind of different ways you have to look at a problem to get through it. But as always, just do your best, keep trying, look at your answers. If you can't get it, try to make those adjustments, write down steps, keep following them, and it'll get better over time.